So here you can see on the camera, we have the belt that we use in a simple system. That is, the belt is attached to the end of the rail to keep it in tension. It's coming inside the rail, and we have these three wheels. Actually, we have four in this case to help a little bit on the stability. Lift on that. So we have four wheels that basically these four wheels are pushing. Usually this system has only three wheels. So with the three wheels, we create the stability of the rail. To make it more stable, but it's slightly more difficult to center, we put four because this bridge is bigger and heavier than usual. And we are using the belt comes up here, goes to the pulley that this guy on the motor has some teeth, and is attached into the other side. So when we move, actually, can we switch? So when this guy rotates, moves a little bit the pulley and helps at the same time to rotate the bearings that are, in this case, are like just more like Del ring wheels to move and advance the machine. This is a system that is good for like lightweight system and it's fast for movement and it's quite easy to build. In this case, we are using this in the mesh of wires just behind. We are using an EMA 17. That is standard type of motor. If you look on the bridge, you can see here the console. We're using an Arduino Mega plus a RAMS. A RAMS basically is a shield that allows a lot of connections on the Arduino Mega. This is like a dumb board. It's just a board that has a lot of types of connectors to connect pre-connected things. For example, we have like cable connectors, we have multiple cable and power inputs, we have condensers, we have some MOSFETs already embedded to power like high power devices, and we have the connectors ready for the stepper drivers. In this case, this shield, we can connect one driver, two drivers, three drivers, four drivers, five drivers. It's a 5-stepper motor shield, plus 1, 2, and 3 power MOSFETs. So basically, this shield is widely used, for example, for 3D printing because we have X, Y, Z, extruder 1, and maybe extruder 2. And we have 3 MOSFETs, one for the heater of the hot end, one for the heater of the base, and another MOSFET maybe to activate another second heater of the second extruder. So this board is widely used for 3D printing, but could be used for other things. In this case, this machine has only 3 steppers, so we only use 3 of them. And the rest of the connections is for activating different things. We have also a LCD screen to have a kind of a nice interface that we connect to one of the connectors on the side of the RAMs. It's a like really modular board. Let's say one of the most modular boards to activate things. You see, there is a lot of mesh of wires because we have a lot of wires coming up. Because this machine is designed that you are able to customize it and use it as you want. It's a machine that is a Frankenstein right now, so it has everything activated and everything ready. So in case you want to put a NeoPixel, draw it live, you just need to connect at the end that we have all the terminals ready for connecting everything. And put it in the code and the machine will automatically launch. Because we have told on the firmware of the machine, the one that we have loaded here, that we have everything. We have 5 motors, we have NeoPixel, we have servo, we have everything is activated by default, even if we don't have anything connected. You see on the the Y and the Z is the same system, but the difference is we have bigger motors, especially on the Z. Why? Because the profile on the Z is huge, and that means we need to move a lot of torque in the vertical. And usually as NEMA 17 is not strong enough, so we use the next level that is a NEMA 23. In this case, we don't have a tool. Actually, what we have is, let's move it. Right now, wait, we need to move a cable. So here you can see we have a screwdriver. Just it's a like the dumbest tool ever, and we used to draw in the sand. Screwdriver. We have also put this blue thing that basically is attached to a servo. So this is a cleaning tool that we can deploy. We move it from 0 to 90 degrees, and we start wiping the sand. So it's a really simple and effective. You see also on the base, we have this blue thinking, this blue blinking thing. So basically it's an automatic probe. You know the CNC that you are touching a button, no? To make the set. In this case, it's actually the opposite. The button is on the top of the machine and basically it goes down until it touches the base. And we have this little, we don't see it really well, but we have this little stick that basically we automatically push it down, we touch and retract back. So we don't damage it. This machine, we call it the Kraken because it's like a octopus that is able to grab whatever tool you design. As the Kraken is in the sea, we put sand, so it's the CNC by the sea. Silly name. We made it. This system is connected to a Raspberry Pi with a camera that is streaming. You want to explain that part a little bit further?
Yeah. So in the Pi, there's a small app running that controls the machine. Maybe we can start the screen.
Okay.
Then you see the camera. You can see the camera as well while you are moving the machine. And this is the interface. So you can control the machine with some commands on the left. Then you can see what you're doing down here in the camera. This also you can see, I'll show you how you can open that camera up in a little bit bigger. You can upload G-code here and you can test with some extra things in here. If I move in here, that's
Bueno, no falta un poco, pues mover.
As we are using sand, it's kind of a soft surface. Do we need to be careful with it, or if we go farther?
So that's why we have this to make the probe in the air, so we don't put the probe inside the surface. So basically, this is the homing point, and the probe will touch in this surface to like we are taking the test because the sand is uneven.
okay. So more or less, this interface controls the whole thing. Cameras in here, you can upload a G-code and it will execute it for you. If you want to reproduce this, well, first you can access this. It's called cncbythesea.fablabmuseum.org. And then there's a login. We'll put the login in the chat so that you can find it, because this is reachable for also remote students.
So right now, this system, last year, we tested on volunteering more or less up to 20 connections at the same time. Actually, it was a 5 who was controlling the machine each time, because it was actually recognizing all the G codes from everybody. Saying that, we don't know exactly how much it will handle all the connections. Sometimes they'll buy overheats and try to slow down the system.
Exactly. Well, at the end, just the limitation itself is that there's only one machine, so you can just control one.
Have you changed that you have that something with connections? Like
It's an app that is guaranteed. Yeah. So you upload something, you can see what you are. So you can see the same screen of the camera, but not the same thing. Okay? Then if you want to reproduce it, if you go to learning the Pablo Vision project, there's a lot of instructions on how to replicate it. The whole setup is explained. You need quite a bit of steps to run this. Basically, there's a server that redirects you to an internal application called CNCJS, which is what we saw here. Then there's a little bit of extra security to avoid people breaking in and things like this. And then a password setup and a script for the video, where you run the same thing that we've been doing with the Raspberry Pi for the solar panel, but instead the streaming of the camera up there. The streaming of the camera as well, if you want to see it, you can go to, instead of workspace, you can say stream up, and you see the stream in large detail. And if you want to as well, if you want to take a picture of this, if you want to take a picture of, say, photo, and it gives you an still in case you draw something and then you want to say this is an image that you can download. Yeah. Everything is displayed on the repo if you want to just reproduce it. More instructions are that if you want to open this, and as soon as you are logged in, you have to go to, and this is important, so that you are able to see, so that, what is the mouse? So that you are able to see the same setup here and everything is more or less ready. You have to go to settings, workspace, and in here you have to import a configuration file. That configuration file is in the repo and is this one, 2021. Okay, you upload that file and you'll see the same thing as you see. Okay.
If you want to do it on our computer, or if you want to reproduce it at home on
No, if you want for this instance to work.
Okay.
Like this, so that you have the right settings for this view. Let's say for you to connect to the right camera stream, to the right USB port and configuration of the machine. This is the setup, and then that's it. The rest, if you want to log in and you want to play already, you see that the machine, when it does that, it starts moving, so it all works fine. Just be careful that there's only one machine, only one stream, so you cannot like all try to move the machine at the same time because it doesn't work. But with respect to the rest, this will be somehow safe. Okay, we'll see this setup if you want in more detail in the code lab, and then if you want to replicate it as well yourself for other projects, and that's it.
Yep. So how the Pi is communicating to the machine itself? The board that controls the machine is a Arduino Mega with a RAM shield. Seems really similar in the process on what the board is on the small CNCs that you have been using. I don't know if it's the small like this CNC that you have been using, and with candles, no? So one of these machines. So basically, this board is kind of it's really similar, but all in one board. It's a custom board that has all the connections ready, the same as this one. But this one has limited functionalities based on the design of the board. And we use serial connection to connect to Candle, that is basically as a G-code interpreter. No, it's not a G-code interpreter, it's a serial command launcher. So basically, reads the G-code and sends line of command one by one of the G-code file. We are using the same concept. We have a serial connection that is not connected to a computer. We just connect to a Pi. And the Pi is simulating, is actually hosting, not emulating, hosting actually the interface that is in this case is CNCJS, but it could be Repetier, could be Candle also, could be whatever, or for example, Universal G-code sender, any software that allows you to send the G-code commands. So one concept of G-code is how we launch the files, and it's quite important. You say that here it says echo busy processing. So if we send a command, let me send a command that is G1, someone is sending. Who has sent everything? Something? Okay, G28, let's just come just in case. You have seen the machine was crashing, didn't know where it was. It was not very easy to set up on the values. So the machine is silly. Luckily, we have configured this machine to not be powerful enough to break itself. And I thought that's also why the reason why the machine moves so slow. So it gives you time to react.
There is no end sensor to detect when this happens.
Yes.
Like end stop? Yeah, there is. Yes,
It's doing right now.
one here and then the other one
On
there.
site,
No,
so only the home inside.
only in the zero origin.
But then why didn't it stop when it reached?
Because we have connected to the machine. Okay, this is about relative position. Let's draw it. So we have the machine, and this is the origin, no? 0, 0, 0. If you, when the machine is here and you switch on, the first thing you always do a machine is, okay, find this point. And it goes by making the movements to find the end stop. If your machine has end stop. For example, the small CNC, this one doesn't have end stop. You cannot find the origin. Wherever you start is the origin. So when you switch on a machine, and if by somehow the machine is here, the machine will think that this is the origin by default. So if you don't home, if you don't do the homing, the machine thinks that this is the origin. So it thinks that actually the workspace is somewhere here. So if you connect and you don't home and you try to move in the negative, in theory, it can move in the negative, but it will move in the positive, but it will collide here all the time because actually it's the physical machine, limit of the machine. In the firmware, you can establish some limits. For example, if you switch on the machine here and you say, okay, move in the negative, the machine will not do it because we can tell to the machine that the workspace is 0 to 500 to 500. We can establish that the actually workspace of the machine is 500 by 100 by 500, let's say. So the machine will only allow commands that are in between 0 and 500 in both X, Y, Z. But the machine thinks it's here, but actually it's here, so it will try to get out. Some machines have end stops also in the limits. So if the machine touches here, we'll actually feel that something is wrong, has reached the limit, even if the machine thinks it was actually in another location. So it's a double end stop machine. We have end stops in both axes. Usually, most of the machines only have in the origin. That depends. For example, the big CNC has in the origin, but the Press 6, that is older machine, has in both ones. So it really depends on the type of machine you are using, etc. So the first thing that we always want to do is actually find the origin of the machine. So we actually are located correctly, and the machines that we are located correctly. Someone has connected, or do we have disconnected from the machine? Connections, let's open. Okay, so when we send a command, right now the machine is in home, so I will not home, we don't need. Let's send G1 X 300 Y 300 Z 50 F 5000. So you see that saying okay, and it says busy processing. The machine will not allow you to send one command when it's actually doing another command. Actually, it will save it. It will save it in the EEPROM memory in general, or the RAM memory. That depends on the firmware that you use. So that basically stores some commands. But in general, we have a limit of commands. That is the EEPROM amount of commands that we can save. So what happens if you send 20 commands and the limit of the memory is 10? It will ignore them. It will only, it's like a list of orders. It's like we have command 1, command 2, command 3, command 4, command 5. So the machine is doing 1. When we finish 1, we'll actually launch the next one. What happened? When we actually check these ones, we actually can add 2 more. We can slowly add 1 line as long as we finish one of the lines to always have the memory filled. So as long as we are like achieving commands, we launch and store in the memory the next one. So that's one of the main reasons why, for example, when we say stop a machine, hide float and meeting controls. Okay, I can't, let's put it here. You send a command that is, for example, stop. It will not stop until it finishes the rest of list of orders, because actually following the list of commands. Your stop command is another command. That's a command that just says stop. So it actually doesn't finish the list of commands, it doesn't stop. In some machines, this might take longer or shorter times. Why? Because depends on how huge is this command. Some commands might be cross the machine completely, and some commands are small. So actually, we just perceive them as shorter commands. For example, a command that moves the machine 500 millimeters takes 2 seconds to be achieved. A command that just moves the machine 5 millimeters takes half second to be achieved. So we feel that it's actually about perception of what the machine is doing. Not actually, the machine is always following the instruction. More things. How the machine knows when, if the machine doesn't know the position and is just activating the motor, like move 10 rotations the motor to actually achieve this position, how the machine knows when to load the next command. Because we, in the firmware, and maybe also in the G code, we can, by defect, we have some values in the firmware and we can override them by the G code. But we have a value of feed rate, that is the speed, let's say at 2000. Let's go with simple numbers. F10 and acceleration 10. That means if we want to move X10, how long it will take to move 10 millimeters if you are moving at 10 millimeters per second? 1 second. So actually it does time estimations based on the speed that and the acceleration that you're using. So it does by calculating actually the time it actually takes to the machine to reach that position, because it knows how fast the machine is accelerating, what is the speed that the machine is moving, and the total amount of movement. So it can know the time. And when actually we are in command number 1 and the second has passed, it launches automatically command number 2, thinking that the motors are not anymore in use. Yeah. That doesn't happen. Like what could happen actually is that the machine is somehow, for example, this. Let's do an example. Can I move this with this? Yeah, not really. Let's. So for example, clear this. G1 X400 F10,000. This happens. I just make a collision. The machine actually thinks it's in position 400. Meanwhile, actually, this is in the same position. The machine doesn't know. So again, what happens? We lost the origin. Relative to the machine, as the machine thinks actually is on that position, not here. The origin is not anymore here. It's here. Actually, the machine could collapse. Actually, that's what you always want to avoid. In this case, we just made this machine, so it's a learning machine, so it's not a machine and it can do this kind of thing. And in case the machine hits, just make some noise that actually the motors are trying to keep the position in place. So basically what we are doing is moving the motor manually because we are stronger than the force that the motor is doing. So it's actually, when you hear like tack, 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 the steps, that we are losing. In motors or machines, that is called the machine is losing steps. And happens a lot when, in general, the mechanically wise, the machine is not acting correctly. Happens a lot, especially in the 3D printers, is because the motors are really weak, because they are meant to be light and fast. When you push the filament, the plastics, and if it melted, if you don't set up the temperature correctly, basically it's trying to push something huge through a small pipe, and you are not strong enough. What happens? Actually, you can't. So actually, the motor is just puck, 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 puck. It's losing the steps all the time. In 3D printers, it's something that you widely see if you don't set up the temperature correctly, or the extruder is jammed. That also happens if you don't do the proper maintenance, or just happens sometimes because of the filament. Like so many things could happen. So why don't you try to connect to the machine and try to send some commands? For example, let's send a few commands. G1Z 200. You will see right now I didn't set up the speed. So what I will do is inherit the previous speed. Ooh, that was close. Let's move that. If I remember correctly, el comando del este es el ventilador, ¿no? M107 es el 200 S90. No. M107 S0. M100 S0. M106. Actually, what we're trying to do is actually use the servo. And the servo is connected to the fan connector. Instead of connecting a fan, we are connecting a servo. And we are sending is the amount of signal. The signal that we give to servos or to fan is a digital signal that ranges from 0 to 255. So we send signal 0, signal 90 will be quarter power, signal 150 will be half power, signal 180 will be 3/4 power, and S 255 will be full power. That in a servo is the different positions, 90 degrees, 0, 180. But I'm trying to remember which pin is connected to the fan, the servo. And if it's connected, because we have been changing the machine a lot. This is what happens when you have a mesh of wire. Esto está conectado. Debería funcionar. I don't remember the fan command, so G-code Marlin M280. Okay. So actually, I just lost the. Okay, so it's connected to the pin fan of the fan. So M105, M106, M107 is activate the fan. But the servos need a special kind of signal that is PWM. In that case, we need to change the command for M280. The command is still using the same pin, but it's a different type of signal that we are generating. Okay. Also, we need to address the servo. So is P1 is extra number 1, P0 is extra number, actually, P0 is extra number 1, P1 is extra number 2. The servo is connected to pin number 2. ¿Es P1, P2, P2, P0, P1? Yep. M280, P1, S0. So imagine that we have like 20 servos. Is the same command. It's P280, P25, or P23, P1, P2, P3, as long as you have connection. Obviously, this has to be code also in the firmware. But the point here is like we could set M106 or M280 and it still will be the same. Actually, you can see right now, I have activated another list. When sending the command M106, M107, this light is on. Actually, while we are doing powering something with 12 volts and lot of amps. Nothing is connected, so no, not a big deal. I think it's 107. Let's see. Yeah. So M106, switch it on. M107, switch it off. I was just activating another thing, not the correct one. If we have a light connected there, we will actually light the light or the fan or actually whatever we can power with 12 volts. Will not matter. So ideally, let's spend a little bit of time try to make a drawing by sending manually commands.
Or you don't need to go.
You mean to make a file for it?
For example, I want to draw a letter.
Draw a letter. Yes, we can use post processor, and in this one you can, for example, I use Grasshopper and I have made my own custom script to export files because at the end is getting a point X, Y, Z, decomposing and adding X number of the position Y and Z. Actually, you can make this with Python scripts automatically, or you can use, for example, Inkscape. You have a plugin that is a G-code exporter because a SVG, vector file, is already a point file, but just we have a visual interface. But actually, the lines are mathematical equations, so by so there are points. There are not pixels. So Inkscape, you have a plugin that you can install that is G-code parser, no? G-code tools that basically transform your vector file into G-code instructions. And you can use in the 3D printers for making 2D drawings because Inkscape is 2D, or you can even use Cura. You can slide something in Cura and send the command to this guy, and it will move in the space. It will not draw, but in the sun. So as G-code assembler, there are a lot of ways, and actually it depends on what you do. For now, I will just, well, I recommend you to launch values manually. For example, the machine right now is limited on the speed. Even if I set up GX500 F 100,000, it will not move faster than this. There is a way in G-code commands to override this. So I challenge you to try to find it. What?
The chat, Pablo Lucian Rocks. Pablo,
It's in the screen. I didn't see it. Okay, I will put the sticky notes.
Pablo, insert Pablo Lucian Rocks.
Actually, but you can also is connected to the CNCs. You will be the same. If you want, like connecting to an Ender or to this one is the same, but you just connect to your computer.
If you want also the microbits.
The
Microbits.
las HTMLs.
No,
Sí, la blue. ¿Está petada? No funciona. ¿Eh? Nada, que petó la máquina. Giuseppe. Sí. Oscar. Oscar, dice que no funciona.
Sí, sí, a mí me funciona, o sea, funciona con esa combinación.
Pero se está como queriendo, porque yo entro, pero digo, bueno, se está. Tienes que bajar de punto. Si solo va a haber una conexión por entrar a la aplicación, pero tenéis que coordinar, coordinar sobre
Tenemos que descargar.
I'm just sending the. El Jason está aquí, ¿no? Sí. Así de grande, like that. You want What command did you send? Who was it?
No, me.
No, because no, because what is going to show? Sí, está un poco. Technical issues. ¿Capital o no capital? Interface states like something. It goes there. Okay. Why? Why not happening? Right, because he was thinking like that you were in the.
¿Cómo conectas? ¿Cómo has podido como conectar a la máquina? ¿Puedo? Vale, Jason, que también puedes soportar desde la
Sí, vale. Dale.
Guys, to connect to the machine.
Guys, 1 second. In the configuration of the machine right now, when you connect the first time, the interface might have a slightly. So we have a JSON file that basically will configure the workspace to have the same settings and camera set. So for that, you need to access the GitLab. So this is the part that you're going to explain now.
Okay, so here in the repo, we go here. It's the repo, okay. Here we need to download this file here, CNC.js app 1922 2021 JSON, and this is the configuration file, okay. Me lo descargo, no sé si lo tienen bien. ¿Te lo has descargado?
Sí, en 2021 estamos ya cargando.
Sí. So you download it, and you will have here on the downloads. Then when you access the CNC by DC, you have to go under settings, and here on workspace, you see here is the JSON file here. So you need to import and select the JSON file that you already downloaded. Okay. Then import here and we'll load. All these parameters are the settings of the machine. So without those, you will not be able to move the machine. So it's the first step you need to do. Hmm?
Si no se rompe el año pasado, ya no.
Tenemos video de intentando que pase la seguridad con esto.
Like basically, we switch on the machine, we don't define and we for 1 month or something like that. Basically, we just access like the new was we install it and go. So whatever we couldn't find, fix it with code, we couldn't. Actually, what among that we using the wiper actually grab sand, put it more sand inside, and like move also the blue thing, so what's outside. So we actually were like managing everything with just another machine.
The height of the sun. Yeah. I wanted or just go down instead until you see that the screwdriver is inside, but not touching the wood, and then right on the body. No, when the tip is not set for the set, the tip is enough. When it flips, that goes. Then it deploys again because this is not wise, but it clicks. And then the screwdriver is now again. And then screwdriver is like 7 The names are GitHub.com, so there's no way, like no outlet for you. The file is open, so you can download it.
But there are certain addresses that has to be for login. I think that's something to sure with every number of the African class, and then we will also that's clear on the sales.
So you can go GitHub.com and then that's outlet.
No tengo ni idea de lo que está pasando.
Mandado un círculo. Ah, vale, ok, ok. No sé si está haciendo, ¿cómo sabemos cuál está haciendo? Porque pone el
When you do this, reset with the red button, that will automatically reboot the machine home and send it to the house. For example, one difference between the study we talk about Marlin and DRBL, that are the two different frameworks. Marlin, like nothing especially dangerous will happen because if there is critical software related for the printers. So actually, there is the key, which are the things in a software. DRBL, the key is key to the process and such a actually the first button on Marlin and DRBL completely different. They react in different ways. When you watch CNC, you pause it automatically. So actually introduces the command as a priority on top of the rest. You can pause it or you will pause it. Reboot.
I click the reset.
Okay.
No, everything that's not there.
Oh,
I think space need.
as I did reset, it should stop it working.
It resets the machine.
I don't Yeah.
So if it says
Also,
that
right now,
I
for
can
example, this interface, CCDS is a G-code sender. These programs are called G-code sender because basically the program is a G-code sender. The Cura has also G-code sender.
a G-code sender? 'Cause I
Sender.
can't- Sender, o sea,
Sends G-code basically. So G-code parser or G-code sender. This one is specific for CNCs. Actually, you see there is no extruder version, like the extruder is another access. It's a 4 access. This case you don't have it. But the framework that we are running is a 3D printer one. So they are able to understand most of the commands between each other, but something, for example, maybe the reset, it's not sending the appropriate command. Why? Because when it reset, what it's doing actually is sending a command.
Okay.
When each time you click on any of the button interface, what it's doing actually is like sending your default command and sending. Basically, the machine only understands commands. So ideally, you should only use the terminal to actually see it. So this is because decode sender, maybe the post or reset, it's not the appropriate for this version of the firmware. That may be why it's not actually reacting.
When Oscar switched off the power and on, it doesn't stop everything that was going on.
Now, why? Here about power management. The PI is connected to the Omega, Arduino Omega, and we have the power supply connected to the shield. The power supply is feeding the shield, the stepper drivers, and the motor, but not the Arduino Omega. So, mechanically wise, it's like imagine yourself that you just cut your head, but still we feed oxygen and blood. Your brain still works and it's actually move your arms. If you don't have arms, but it's still sending the commands. But you don't have any mechanical thing to actually react.
Because we stop and we check that it stopped here, and when it stopped, we switch on again.
Exactly. So what Oscar did is switch off the power supply. Basically, we cut the electricity to the motors, but the microcontroller was still sending the commands. Even though it was not actually moving anything. It's like cutting the arms or the legs to the machine, but the brain still ignoring and working the same as it was working before.
And everyone can see the code someone is putting, like I see the circle that I sent.
Yeah.
And how can we remove it?
Erasing the file. So this is in the review, so it's not sent to the check. That you
Okay, it crashed.
Okay, Oscar, can we send like if I hello the G code in the lines for me crash to communicate another time and launch something? Can we do it like this or it's risky?
Right, this is for experimenting, however you want.
Okay, so we're all technically now.
Just habíamos hablado.
Have to coordinate, otherwise he'll be here for 5 hours.
Is there any difference on the code between area and Arduino?
the command like there is no difference in the code. It's what the code framework can interpret and can read.
I don't know.
For example, the code guide that we are reading is the marketing. That is standard. We have more or less 400 letters. The area is way more limited in that aspect because of multiple letters. Actually, the total amount of the area commands that can read is around 50%. That's 10%. The area is a system built for stability and robustness, meanwhile one is for flexibility and possible expansion.
and you can just clear the margin.
So right now, this machine is marking. No, it's because this machine is, we have marking here. And here is marking for us, but through a eco standard that is more prepared than the real deal. But still, as you are sending manually to the command line, it will send it. No, it's interesting process. For example, the machine that we have, the OTC, if you send that command N 160, doesn't know what it is. You will take on one. So here, size, for example, N 655. Okay. Oh, right now the printer says 100. If there is something that sends an error to the machine and tell it to completely, just disconnect it. So we need to reset. How we reset? In general, we can close and open point that will automatically reset.
All of us have this. We're all connected, we all have to disconnect.
No, we can keep it at the same time, but sometimes my computer will be different.
Okay, yeah.
On the board,
Something. No. Yes, I just want to explain one thing. If you can just have a look over there, please. So, ¿cómo hago zoom en esta cosa? No quería, pero ahora ya está. Ok. Okay. So there's one thing. So this is the Pi down here, okay? And this is the server that is running inside the Pi, and this is the application. When you connect each time, so this is, I don't know, Edu, this is Neil, this is whomever. Okay. See, da igual, la parte doesn't matter. It's just the part that I want to show is this one. So this is the CNCJS application that is replicated in all of you. Okay. You see a version of that application in each of your computers, but you don't all see the same. The same way that you see something different when you log into your Facebook, on whatever other Facebook, no? The important thing is that each of those have control over the hardware, which is the Arduino here that controls the machine. But there's only one connection here. So if someone opens the connection from their browser with that instance of the application in the Raspberry Pi and someone else does it as well, then it collapses, especially if you start sending things, because this is a bottleneck. Let's say there's only one machine, so only one person can send things at a time. Otherwise, the machine will be like, someone send me a G0 whatever, and then someone else send me something else. It's accepting things, or maybe with only one connection, it will only work with one clean connection, but not with several at the same time. So when you log in here and you go into connection, if you open it, let me clear this. If you open it and start sending things, and other person has opened it and started sending things, the machine will not know which one will have to listen to. So you need to coordinate and say, okay, I'm gonna send something, or maybe you can join together and see in groups or share your screen or something. And also the people at home, this is open and has a public IP address that you can reach. So also coordinate as well and with the Zoom or something like that. Okay. So exactly, the machine is going to be here for quite a while.
Even if the lab is closed.
We can put some lights so that you can see it. But it's not, I mean, we didn't keep it like here.
You want to all try to or something?
Actually, last year they brought the cleaning part and we just have just a little metal. They take more time.
Do you want to try to do something all together now? You just move it until you need, and that's it, like you said. Yeah. So you want to stand from your laptop, and we can all see.
But if you interrupt, for instance, if she's sending something and you connect, the Arduino resets. You know, so every time that there's a new connection, to open the connection from the Pi to the machine, it starts every time. So it opens the connection. So if you open that connection while she's sending something, it resets and what she's sending is over. Yes.
Just one question. How come some people have this?
I guess it's Adrian's circle that we sent.
Okay.
Ah,
You send that circle.
yeah. Difference between machine position and work position, what is it?
Machine position, I guess it's zero, global zero.
Right.
And the global zero of the machine and the zero that you do. So you have lots of
Okay. That's because how the different firmwares are interpreted. So, for example, a pre-printed always starts from the absolute origin. Always uses the absolute, or actually, ideally, should always use the absolute origin. CNCs, on the other hand, typically are bigger machines, and you might use relative origins. That is when you put the material in whatever piece, and you say this is the zero. That's why this the CNCBS is ready for using CNCs, aka GRDL or similar, and it gives you the relative positioning possibility. I mean, well, Marley in general we have it, but it's not widely.
It is interesting to, if you want to do zero here, because you always go instead of here. Either you change everything so that your drawing is 50-50, it's white, or you do a zero here, and then you send it relative coordinates, that's it. Yeah. So you can go here, set the zero, and then set the drawing, and it will reference the drawing that you sent from this one. Like the basic comments, they were available in the margin, right?
G-code, just Google that go get like G-code Marley.
Who sent that? You did?
I guess this is possible. Actually, also last year we did G-code visualizer if you want to access your G-codes. Here, guys, in projects, learning, actually in projects, you go up. This is our repos, CNC machines. You have a G-code visualizer. We did a simple visualizer interface that basically you upload a G-code and shows you actually the commands like in color, air traveling, zeros and G1s in gray. So silly. And in case you have layers, the layers. If you want to check, if you have a G-code file and you don't know exactly what it is, you can visualize it. Still, like the software here does it quite good already. 3D view, yeah. Yeah, no, it's no. I think it's bigger, but I don't remember the size. Hmm? Sí, es rara. Lo mejor debe tener el cable un poco estable.
Here you have exact, I don't know, x-axis, y-axis.
It's like, exactly. It's just. So I think it was like almost 11. So after. Yeah. Eso es. The one where the one. That's it. Just maybe bring it down a little But it's also the You know what we can do? We can just slap them. We can slap them with this. You know, like this back. The nose.
Yeah, that's all. Like some machines, you need to repeat to it once. You need to set it for that. Yeah, and that's about.
It's gonna be like here. Okay. What? Why? Yeah. X what? X no. X Y. Right.
In general, the free is what?
Yeah.
Who?
No. I think bring the.
El tornillo aquí dentro.
What are you trying to do?
What are you doing?
I think.
¿En serio? Ah, eso estaba en la HTML.
Like, are you wanting to do the back? I like that.
Ah.
Punchy.
M280 es 0.
Ah, this is also, it doesn't have like that.
Have you seen Have you seen this? Guys, are you subscribed to the issues of GitLab? No, no, I suppose no.
Well, we are automatically.
Yeah. Did you saw yesterday presentation?
Can you actually?
Did you saw this yesterday presentation? Okay, just to put you in context, Fran is one of the instructors of the academy that is here since the beginning of the academy. Like, it's one of the oldest instructors of the academy. And he was in Sitges. Actually, he worked also here. Then he right now is in a van traveling around the world, like founding labs. And he makes like YouTuber video, like videos of the Fab Academy. Actually, if you go to their YouTube, it's quite fun. It's, yeah, how to survive the Fab Academy. Okay. Side comments. um, sí, un segundo.
Convención y todo, y digo, daba 0 voltios.
Le explicamos todo lo que tenemos.
Entonces, aparte de los 0 voltios,
Okay, so last year,
no arrancar, desconectar y volver
Because we have only one week.
yeah, like we have reconsidered on the building the machine, but we're gonna give you like tips. Okay. Tenemos el field por ahí abierto en algún sitio.
Sí que creo que para y podemos durante eso
Okay. So SPML. The 6-pack machine came up last year. Confinement, you know, we have a lot of time at home, and we try to make it as cool as possible. So we went for the idea of designing a really small, like, actually the official name is 6-pack milling machine because it's the size of 6 parts of beer. But it's like simple personal mobile lab. So basically it's a ultra simplified machine that is not good for anything. but it's good for learning. That is, accuracy-wise, you cannot mill like plastics or wood, but for example, you can mill like whatever you find at home, like a piece of foam or a piece of soap. And the point is here to learn how to build a machine, like let's say the same as an industrial machine, but without reducing the tolerances, like the price and everything. But the conceptually is still the same. We have access that they move with stepper. We need to configure exactly the same things. The firmware that runs inside is exactly the same. So Oscar did an amazing job on designing the electronics. And last year, we made a big move on the electronics, and we try to produce these like custom boards that are let me shoot this in big speaker view. Okay, I'm not a speaker. I don't know why. Pin. Okay. Yeah. So this is ISP, and we basically make it as modular as possible, and we design like a microcontroller shield. No, it's not a shield, a board that you're able to connect to everything. So basically, it's ISP that has all the pins ready, like an Arduino, but in inverted. We enable like some buttons for programming, voltage regulator, some LEDs to allow you to know what is happening, and a button and a slider to program it. So it's favorable, and we send like a lot of them to manufacture. Let me. ¿Por qué no enfoca? Yeah. So it's the same one, but like we send to manufacture the PCBs, and you can solder. So you have a lot of these guys in case you want to produce your own, or you can make it completely favorable. So it would be nice if you can produce both, and you can have like 2 mini powerful super Arduinos with Wi-Fi Bluetooth that you might use in your final projects or not, or just have it for fun. So it's really nice, it's really powerful. And we designed a shield for machines. We designed a shield for making blimps and RC controlled cars. So as you have all the pins, you can design whatever shield for it, and you still have a really powerful processor. Together with that, we design a board that you can actually connect it to. That is this CNC shield. The same as in this machine uses a ramps that is quite of generic shield. We designed this expansion board. Let me focus. Okay, here. So basically, this is a board that allows you to connect up to 3 stepper drivers. So that means we can connect 3 axes. We have a voltage regulator. Sorry, it's like here. A voltage regulator to manage electricity. So it is a mix of standard industry boards like these stepper drivers, this power regulator, and a shield that is custom that we designed to fit in like most of the educational programs that we do, and allow you to control like small machines, etc. We have also this guy is a logic level converter. We will go on to this into output and input week, because it takes a little bit time to explain what this component is. And we have a MOSFET to connect, for example, a spindle motor, a DC motor, the same as the milling machine, a DC motor. And we have a lot of pins ready to connect future things like end stops, fans, water cooling in case we want, etc. So we have a lot of free pins, in a lot of different connections, and we have like the same as you might find in any like board that you can buy, like a ramps or a GRBL shield, but designed for the ESP. That is a way more powerful platform. And right now there is a big movement in both Marlin and GRBL to allow to these newer processors, because they can compute faster, they have more memory, and they can do things in general better. Based on that, we started this project also because we found a fork of GRBL. GRBL is, I will show you by sharing the screen. Oops. Sharing screen. Yeah. GRBL. So GRBL, this is the repository of the firmware that you can download, and has a upload guide and everything. For example, you have usually this one is 80 mega, the Arduino Uno microcontroller and the Arduino board, and give you instructions and what is the new improvements. So some people were interested in using the new kind of microcontrollers like the ESP or SAM controllers that are way more powerful, and they make a fork that they enable those firmwares. So actually you say, okay, we have GRBL that is a super steady platform, super good. I mean, it doesn't have as many options as Marlin, but every time there is an update in GRBL, it's because it has been proven that it works really, really reliable. So we have a really steady software that we can run in the microcontroller, so we design everything around it. So it's called GRBL ESP32. It's a port of GRBL firmware, and this guy also actually is doing this kind of the same. There are two guys that are doing this. They are doing the same, designing their own custom shields because actually they don't exist in the market, but they will exist. And actually, this guy sells right now the shields.
And so this software, you just flash it once.
We use
Arduino or something like this in the board, and then once it's forward, it works.
Exactly. So what was the move of using this instead of like the standard one that is Arduino with a shield? Is first, we can control it through Wi-Fi. So we just need to power it and we can work with it through Wi-Fi. So we can send commands the same way that we were doing right now, wireless. We can also control through Bluetooth. There are phone apps that control GRBL for Bluetooth. So you can use like the same as the CNC. You have the little command to actually move the axis, etc. We can do the same with the phone. So it's really powerful, and in the future, actually everything is moving in that direction, or we hope so. Right now, it's actually moving. So the point right now is you have we don't want to take too much time on your machine week assignment, but we give you different options. We have CNC shields, Arduino ones. We have RAMs to control your electronics, so you need to make your own. Or you have like the Arduino, the ESP32 shield that we think is really useful, and you can also use maybe for your final projects later on. Or like maybe at least the brain, because this one is swappable. You can just connect and disconnect. Actually, this one I think we just take from somewhere else. You can see that this one, for example, is green because this is the big one that we just manufactured. We found out some issues, like the cable was not perfect. We also made mistakes, like routing was not perfect. We were missing some diodes. So we produced a V2 that are the white ones.
Just put your hand behind it.
Yep. So this is the 2.21. So actually we have a lot of them, and you have the shields, and they are there. So to make it easy, all the components are marked on top of the shield. Like Oscar did an amazing job, like labeling everything. So we need to assemble it. You just need to take the shield and start opening the boxes and solder and put it in place. As if this is a down board, we don't need to program it. The only one that we need to program is the Arduino.
This is a what? Word dumb?
Dumb board.
Okay.
Doesn't have any microcontroller.
Okay.
This got chip on the board, you know, that I saw the ESP, there's another small one. What is it?
Yep.
No,
Is FTDI.
no.
This one, no?
Yeah.
Is FTDI.
Okay.
So for making this machine, we want to simplify the process of building machine as much as possible. We found out these small rails. That is a made-out rail that works out of the box without costing like 200 euros. So basically, it's a stepper motor. As you see, it's a really, really small stepper motor. This kind of stepper motor is the ones that you find inside your DVD readers, like Blu-ray readers, etc. As a little gearbox to increase a little bit the torque, because the power of this motor is nothing. It's just to move a CD drive. And we have No, okay. We have a little LED screw and a coupler to connect the LED screw to the motor axis. And we have the sliders. As you see, this is simplified. We don't use bearings. They use like, this seems like Teflon. We don't know, maybe it's Delrin or nylon to slide and reduce the friction. So it works out of the box the same as the axis works in the CNCs or the bigger ones, but in a like economic format. What the best point of these ones is they simplify and make it cheap as possible. For example, we have backlash. We don't see really well, but we have like 0.5 millimeter movement in both directions. But that's why we say that it's not good for making PCBs or milling hard things. On the hardware side, basically, as you have a rail ready, have a few of them here. Well, this one are wrapped, but they have holes that are pre-made, and you can start like gluing them together or screwing them together to make a platform that moves X and Y. If you connect another one, you have Z. If you go to last year documentation, you can see like the different students were combining different ways. For example, you can have 2 for the X and have a flat platform, for example, a big sweeper. Or big no, usually because the movement is only like 7 centimeters, 7 to 8 centimeters in the length of the rail is quite small. Also, as there are small motors, power demanding, we don't need a power supply. So basically we are using a small like power adapter, like laptop charger to power the whole machine. This one, for example, uses a small brushless motor, but we can also use a DC motor, or in this case, for example, it's using a DC motor that is an air pump that produces pressure to actually push through this syringe. For example, this is last year David one that he just make adapter to combine the 3 axes to light paint with LED. This is an infrared sensor, so in the moment the camera starts taking the picture, they send usually an infrared blink, gets this one, activates the play of the file that was preloaded on the machine to actually start lighting up the LED based on the G-code comments. So it's a light painting machine.
Nice.
This CNC shield has also a SD card holder, so that means we can store G-code files inside, the same as you will do in a 3D printer. That in general, for example, GRBL is something that doesn't allow it, but moving to the ESP32 allows to this kind of expandability. We can try to connect one. ¿Esto funciona?
The ESP32 has enough memory to store G-code, otherwise without the SD card.
Sorry?
We can store G-code in the ESP32.
We can, if they don't recommend, because we are using a lot of the memory, and we are using also actually the memory inside the ESP to store the web page to control it.
Okay.
So we don't need to use any firmware. Basically, we have access to a website.
No, es que no te va a me parece fácil.
¿Sí?
Me parece fácil.
Ah, mierda, es verdad. Vale. So right now, let's say we have a problem. We have configured it to work with Wi-Fi, so I cannot disconnect my consume. So Joseph will do it with his laptop. The good point is wireless, so basically we just plug it. This guy. Esto no está encendido, ¿sí? Yep. So it's on, and Joseph is going to connect, and we're going to zoom with his camera.
The thing is,
Joseph, ¿se conectas?
you don't have to.
Sorry.
You don't have to do anything. The idea is that this gives you a better place.
Ponlo aquí.
You can either use the standard laptop thing or in-house. This is an in-house storage that we have. That requires us to do that as an educational tool, but we don't have to use it. We have a lot of like boards and things like that, so that you can play, make your own designs, improve it, etc., etc. And everything as usual is all open, so if you want to modify anything, pull requests, collaborate, take the project, set the machine, whatever, you can. So if you want to improve the electronics, if you want to make new designs for, there was people doing 5-axis machines, there are people doing light painting, whatever. The boilerplate, whatever, and we experiment, but we can keep using it afterwards, we can take it home, that's the machine.
So for right now, for example, you said what it did is just connect, like change the Wi-Fi network. In the moment it's in the Wi-Fi network connects, the browser automatically opens and launches this web page. This page is stored actually in the Arduino, inside the BSP. So actually the interface of control, the G-code sender, is also stored inside the machine. So we don't need anything to connect it. Actually, we can connect to this interface also through the phone. If you connect to the Wi-Fi, you can connect to the phone and control it as a web page. As you see, it's a similar interface that the one that you were just using with the Kraken. That is, we have like the commanders, like it's mainly dedicated for CNC, so we have quick touch. So it like overrides, and we have here the G-code commands to send them. And we have the SD card files that don't know we have an SD card, so let's try to refresh. No SD card. Yeah, and we have here the files that are stored in the SD card of the machine right now. So we can try to move it. Then so it's one of the small machines. Like hardware-wise, hardware-wise, you see, it's not really complicated. We have different versions. This one is basically is Acryl. This one was the big one. This is the B2 that is simplified, and we use basically like an H3 of laser cut acryl of 5 millimeters, and it's bolted together, and everything is assembled. Hardware-wise, it's not like NASA. Kind of. This one is slightly more clean because it's all 3D printed, and it's actually meant to be 3D printed in the ender. So it's actually 2 parts. We have, we can show in the repo, it's easier. Share screen, or I can show you in the, I have it. SPML. ¿Dónde están las fotos? Imágenes. So actually it's meant to be assembled 3D printed in like 4 parts, 4 big files that you send it, print, and you can wrap it. So in this case, the electronics are on the back hidden. Obviously, this takes like 2 days to be printed because each file takes like 12, 14 hours, but you don't need to worry. The other one is like 3 minutes cut. Depends on what you want to do. Of course, this one is bigger, this one is smaller. This one is more easy to customize than this one.
But the working surface is the same?
The working surface is exactly the same. It's 70 by 70 by 30. Ridiculous. But enough to, for example, yesterday, well, Arman did transform it to a kind of 5-axis machine, adding 2 more steppers. You say, how?
Does it work?
This, yeah, he moved actually. Like the problem is he couldn't generate a file for a 5-axis because generating 5-axis is quite complex.
Okay.
The problem was like actually how to make a file. So we have only 3 steppers. So what he did is use the other leftover pins to make his own shield with 2 extra stepper drivers. I don't know if you can see it.
I think so, yeah.
And maybe
Yeah,
another
so-
question.
This board,
¿Dónde es que lo ponemos?
that connects to the, so it's an expansion board of the expansion board.
Okay.
It's actually in the RIP. Well, we have always been Fabacan documentation. So this is the board, and he expanded to this other board. You see, it's a mess of cables because he explored with a lot of motors and testing. And
But where do you, how, what's the,
how you connect to the other chip. Okay, in this case, he went into the firmware. Right. Vamos a enseñar aquí. Share screen. Sí. So this is the repo that is also on the GitLab. This is the firmware. So firmware 3-axis brushless motor. You have a lot of files for configuring the firmware.
Okay.
Like we have one file to read the files for the SD card. We have one file for the limit, the end stops. But in general, it's way easier to configure them. For example, we went to the machine, and this is, for example, for a 3-axis, 5-axis. This is where we set up actually the definition of the pins of the machine. We say that pin number 25 is the one that controls the direction of the X motor. Pin number 26 is the one that controls the direction of the Y motor. So we can always change these configurations. It's about the same as you activate an LED. You can say, no, it's number 20, it's number 21. So in here, we have the definition. It's the same or machine definition. In this case, we made our own for this Arduino because we designed completely the board. So we say that the X is connected to GPIO number 12. Y is connected to GPIO number 14. So what Arman did is instead of using, for example, coolant, he just put access 5 in the pin 21, access B in the pin 16. So he changed the pin definitions to expand it.
Yeah, because now that when you say that there are already like frameworks that you can use already set, makes sense.
Exactly. So happens the same. For example, you have the base of this machine is an Arduino Mega. Arduino Mega is predefined machine. It's a predefined machine. But the RAMs, we have RAMs B1, B1.2, B1.1, B1.3, B1.4, B1.4B. And each one, the pin definition is like this. So you always need to update this file, that is the pin definitions, which expansion board that you actually use. Marlin has already like a big catalog of commercial boards available. CNC Shield, the GRBL standard one, the 1.1, also. In their case, we just created our own, and we try to follow as, well, Oscar tried to follow us more or less the standard definitions, so it worked more or less out of the box. But in case you want to make a modification, you don't want to use, I don't know, a spindle, you want to use an LED, it's about changing the pin number. Otherwise, it's still the same connection in the same location because its encode is routed through the PCB. So we are trying to give you like establish opening a lot of possibilities for this week that we have like RAMs boards that are. This is the machine. So for example, this is the expansion board for GRBL on Arduino. You can see from the subscreen. This is actually system of Arduino. GRBL is just an Arduino Uno because the board is small, because it's really efficient, it's reliable, and we don't need to make more than 4 modes. So that's why they do that. No, here is where we connect. The stepper driver. Yes, sir. This is the stepper driver. So these are just made up connections ready to connect. Why? Because stepper drivers, there are like more or less 6, 7 types. Depends on the size of the motor that you want to reach, the definition, and the power you need. We have like they all do the same, but they do the same with a little bit more noise, a little bit more torque, or slightly more accurate, or slightly more expensive. But they exactly do the same. And we don't need to go that deep inside. But for example, newer generation of these guys, this is something that right now is changing in the Philippine world. We have the what we call ceiling stick. You have noticed that the Prusa, the MK3, sorry, yeah. These are the shields. These are the ramps shield, and this is an Arduino GRBL shield. So right now there is a movement because these stepper drivers, they are becoming better and better and better with new. This is a microcontroller, but just already with a firmware that you don't need to change in general.
But could you modify it?
If you want, yes. But I don't know no one yet that has done it. But you can. It's doable. So these guys have become better. For example, Prusa uses the new generation of these guys, like the MK3. If you hear the MK3 working and the MK2 uses the old one, the MK3 is the new one. The biggest change is the level of sound. One is like moving, and the other one is like. We will go into that food week, deep into that. Like takes at least half an hour to explain all that. And it's like the bit of the previous knowledge. But in general, these guys, they do the same, but they're different styles. Like for example, we use the purple one. In general, they are the worst ones, but educational wise, if you make a short, they tend to don't break. As simple as that, because they are more robust, but they make more noise. That's why this machine makes more noise than, for example, the 350. Because we use the purple ones that are more resistant, even if they are slightly older. So for this week, machine-wise, you're free to do whatever you want. We recommend you to don't stop with making your PCBs. You need to make your PCBs, do it. But there's platform that allows you to really fast assemble a machine. Depends here what you want to do. It means how many actuations you want. You need a lot of actuations. For example, they can go to a RAMs. Pin-wise has 56 connections. You want to have more variety. This is if you want to use firmwares predefined. You can always use Amiga with this guy and code your own program. You don't need to use your own, like a custom-made firmware. Controlling a stepper driver is like 20 lines of code. Just controlling a stepper driver, a motor, a stepper. The rest of things is like hardware accelerations, software velocities, etc. That for moving a machine, just making this movement is not needed.
Question, non-related assignment. So we need to use a model, right? Like we couldn't do one of the examples that Neil showed, the Theo Johnson like point powered beast.
Needs to be electrically activated.
You need to control it.
Okay, but like if it was something like that and it had a motor that drives the mechanism rather than different axes, would that be okay?
Yeah.
But if the motor cannot be just running,
Okay.
you need to control something on the motor.
Imagine the Tate Johnson that is like walking and does the Michael Jackson. I don't know.
And the beast follows it.
Yeah, and you can program it to do different movements.
So the robots.
The robots, good question. I have asked, we'll check in a second, the chat instructors. Because they were, okay, explain to Oscar.
Your idea.
Explain it. Explain it again. Do you have more ideas?
Machines that fight each other.
Like one easy base for everyone to save time, and then maybe each group design one weapon that moves with another motor. And maybe was proposing also maybe to use infrared detector, like if you put the light in like laser tag and kill the opponent or stuff.
Nos han ignorado completamente. Nadie ha contestado. Eso es que nadie se ha montado. Eso es nada más lo que hablamos.
How does it work though?
Es más, por ejemplo, no puedes dar si lo configuras de cierta forma, sí. Lo más sí, dependiendo de
Or you put sensors in, but.
sí, no, textualmente. Vale.
But the thing is, all that, the funds where you can.
Ya. ¿Sí?
No,